Factors and multiples. Factor. A factor is a number which divides the given number without leaving any remainder. 5 multiplied by 7 equals to 35. 5 and 7 are factors of 35. Remember, every number has at least two factors, 1 and the number itself. 1 is the smallest factor of a number. The number itself is the greatest factor of that number. A number has finite number of factors. Multiple. When a number divides the other number such that there is no remainder left, then that the dividend is called the multiple of the divisor. For example, 35 is the multiple of 5 and 7. Remember, every number is a multiple of 1. Every number is a multiple of itself. Every multiple of a number is greater than or equal to the number itself. There is no end to the multiples. Test of divisibility. We can test whether a number is divisible by another number or not by following the given rules. Divisibility by 2. A number is divisible by 2 if the last digit of the number is 0, 2, 4, 6 or 8. For example, 42, 128, 374, 910, etc. are divisible by 2. Divisibility by 5. A number is divisible by 5 if the last digit of the number is either 0 or 5. For example, 70, 345, etc. are divisible by 5. Divisibility by 10. A number is divisible by 10 if the last digit of the number is 0. For example, 80, 120, 790, etc. are divisible by 10. Divisibility by 4. A number is divisible by 4 if the number formed by the ones and the tens digit is divisible by 4. For example, 78,456 is divisible by 4 as the number formed by the ones and the tens digit is 56, which is divisible by 4. Divisibility by 3. A number is divisible by 3 if the sum of the digits of the number is divisible by 3. For example, 78 is divisible by 3. Since the sum of the digits 7 and 8, that is 15, is divisible by 3. Divisibility by 6. A number is divisible by 6 if it is divisible by 2 and 3. In other words, a number is divisible by 6 if its ones digit is an even number and the sum of its digits is a multiple of 3. For example, 19,566 is divisible by 6 because it has 6 in its ones place, so it is divisible by 2. And also, sum of the digits is 1 plus 9 plus 5 plus 6 plus 6, which is equal to 27, which is divisible by 3. Divisibility by 9. A number is divisible by 9 if the sum of the digits is divisible by 9. For example, 29,286 is divisible by 9 because the sum of its digits is 2 plus 9 plus 2 plus 8 plus 6, which is equal to 27, which is divisible by 9. Prime and composite numbers. A number which has only two factors, that is 1 and the number itself, is known as prime number. If a number has more than two factors, that is 1 and itself, then the number is a composite number. For example, the numbers 2, 3, 5 and 7 are prime numbers because they have only two factors, the number itself and the number 1. And the numbers 6 and 4 are composite numbers. The number 6 has 4 factors, 1, 2, 3 and 6. The number 4 has 3 factors, 1, 2, 4. Remember, the number 1 has only one factor. It is neither a prime nor a composite. 2 is the only even prime number. All prime numbers are odd except the number 2. All even numbers are composite, primes between 1 and 100. Here is a simple method of finding prime numbers from 1 to 100. Cross 1 as it is neither a prime or a composite number. Leave 2 as it is a prime number, but cross out all the multiples that come in the table of 2. Leave 3 as it is prime but cross out all its multiples. Leave 5 but cross all its multiples. Leave 7 but cross out all its multiples. The numbers that are crossed out are all composite numbers, and the numbers that are not crossed are all prime numbers. Two primes with a difference of 2 are called twin primes. For example, 11 and 13, 17 and 19, 41 and 43, etc. are the pairs of twin primes. Primes factorization. When a number is expressed as the product of prime factors only, then that expression is called the prime factorization of the number. For example, 15 is equal to 3 multiplied by 5. Here, 3 and 5 are prime factors of 15. Let us learn to find out prime factors of the given numbers. Example 1. Factorize 36 into its prime factors. Solution. Step 1. First, divide 36 by 2. Since 2 is the smallest prime that can divide 36 completely, the quotient is 18. Step 2. Again, divide the quotient by 2. The quotient is 9. Step 3. Divide 9 by 3. The quotient is 3. Step 4. Divide 3 by 3. The quotient is 1. So, 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. Remember, the divisor must be prime numbers. Example 2. Factorize the following numbers into their primes. A. 60. Solution. A. 60 divided by 2. 30 divided by 2. 15 divided by 3. 5 divided by 5. Thus, 60 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5. This is the prime factorization of 60. B. 84. B. 84 divided by 2. 42 divided by 2. 21 divided by 3. 7 divided by 7. Thus, 84 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 7. This is the prime factorization of 84. Highest common factor, HCF. In the previous class, we have learnt about common factors. Let us find out the common factors of 18 and 24. Factors of 18. 1, 2, 3, 6, 9, 18. Factors of 24. 1, 2, 3, 4, 6, 8, 12, 24. The common factors of 18 and 24 are 1, 2, 3 and 6. The highest common factor HCF of 18 and 24 is 6. The highest common factor HCF of two numbers is the greatest number that divides both numbers exactly without leaving a remainder. Finding HCF using the prime factorization method. Let us find HCF of 36 and 60. Prime factors of 36. 36 divided by 2, 18 divided by 2, 9 divided by 3, 3 divided by 3. 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. Thus, the prime factors of 36 are 2, 2, 3 and 3. Prime factors of 60. 60 divided by 2, 30 divided by 2, 15 divided by 3, 5 divided by 5. 60 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5. Thus, the prime factors of 60 are 2, 2, 3 and 5. The common prime factors of 36 and 20 are 2, 2, 3. Thus, HCF of 36 and 60 is equal to 2 multiplied by 2 multiplied by 3, which is equal to 12. Answer. HCF of 36 and 60 is 12. Find the smallest prime factor of the number and divide the number by this smallest prime factor. Again, divide the quotient by its smallest prime factor. Continue this process till you get the quotient as prime number. Finding HCF using the common division method of prime factorization. Example 2. Find the HCF of 72 and 90 using the common division method of prime factorization. Solution. Step 1. Divide both numbers by the smallest common prime number. Write the quotient below the numbers. Step 2. Then divide the quotient by the smallest common prime number. Step 3. Stop when you finally get the quotient as a prime number. Hence, the HCF of 72 and 90 is 18. HCF is the product of all common factors. HCF is equal to 2 multiplied by 3 which is equal to 18. Example 3. Find the HCF of A. 20, 25 and 45, B. 15, 21 and 28. Solution. A. 5 is the common prime factor for 20, 25, 45. Thus, 5 is the HCF of 20, 25 and 45. B. There are no common prime factors for these numbers. The only common factor that divides the numbers is 1. Therefore, the HCF of 15, 21 and 28 is 1. Finding the HCF using long division method. To find the HCF of two or more numbers, we have another method called long division method. We generally use this method for finding HCF of large numbers. Example 4. Find the HCF of 150 and 250. Solution. Step 1. Divide the large number by the smallest number. Step 2. After dividing, the remainder becomes the divisor and the original divisor becomes the dividend. Hence, divide the divisor by the remainder. Step 3. Divide the second remainder by the first remainder. Step 4. Continue this process by dividing the divisor by the remainder till we get last remainder 0. So, HCF of 250 and 150 is 50. Example 5. Find the HCF of 198 and 122. Solution. Divide the large number 198 by the smaller number. Therefore, HCF of 122, 198 is 2. Example 6. Find the HCF of 75, 135, 225. Solution. In case we are given more than two numbers, the following steps are followed. Step 1. We first obtain the HCF of two numbers. Generally, we take two bigger numbers. Step 2. Then, we find the HCF of the third number and the HCF of the two numbers that we obtain in step 1. Thus, the HCF of 225 and 135 is 45. Now we find the HCF of 45 and 75. Thus, the HCF of 75, 135 and 225 is 15. Lowest common multiple, LCM. Let us consider the multiples of 8 and 10. The multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. The multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The common multiples of 8 and 10 are 40, 80, etc. The lowest common multiple or LCM of 8 and 10 is 40. Thus, the lowest common multiple LCM of two or more numbers is the smallest number that can be divided by those numbers exactly without leaving a remainder. Finding the LCM by prime factorization. Let us find the LCM of 8, 12 and 60. Step 1. Find the prime factors of 8, 12 and 60. Thus, factors of 8, 2 multiplied by 2 multiplied by 2. Factors of 12, 2 multiplied by 2 multiplied by 3. Factors of 60, 2 multiplied by 2 multiplied by 3 multiplied by 5. Step 2. Multiply the common factors and the factors that are not common. Hence, LCM of 8, 12 and 60 is 120. 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. Finding the LCM by common division method. Let us find LCM of 12, 16 and 24 using the common division method. Step 1. Divide the given numbers by the smallest prime number that can divide at least 2 of the numbers. Step 2. Write the quotient and the undivided numbers in the second row. Step 3. Continue the process of dividing by a prime factor which is common to both or more numbers till we reach a stage where no more prime factor is common to two numbers in a row. Step 4. Multiply all the divisors and the numbers in the last row. This product is the LCM of given numbers. Thus, LCM is 2 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 2, which is equal to 48. Example 7. Find LCM of the following numbers. A. 8, 10, 15, 18. B. 6, 15, 21, 30, 35. Solution. A. Thus, LCM is equal to 2 multiplied by 3 multiplied by 5 multiplied by 4 multiplied by 3, which is equal to 360. Solution B. Thus, LCM is equal to 2 multiplied by 3 multiplied by 5 multiplied by 7, which is equal to 210.